So as I was saying, this here is your machining operations toolbar, and as you move across the toolbar, you'll get a hint indicating the type of operation that you will be selecting if you click on the tool. So drilling is the first. There are a bunch of drilling tools, as you can see if you click on the flyout, and then there's pocketing, facing, and so on. Today we're going to be looking at facing, so I'm going to just click on the facing tool. Turns orange. You have to tell CATIA where you want the facing tool located in your project tree. I'm going to locate it inside the manufacturing program. So right now there are no operations in the program. If there were, then I would have to click on which of the operations I want to add the facing after. But in this case there are no operations, so I'm just going to click directly on the manufacturing program, and it will insert the operation into the program, and what you will see in front of you is the dialog window for your facing operation. So this allows you to define all the parameters that are needed to set up a facing operation and to generate the toolpaths for it. I'm going to just move this over a little bit. So as I said previously, a lot of these dialogues have these images on them which are pickable, and as you move your mouse over them you will see that different things highlight. So this allows us to select different types of geometry to set up the facing operation. Before we do that, however, I'd like to draw your attention to the top here where you have these tabs, and this is something that you're going to see time and time again in every single operation dialog, these 5 tabs. When you select an operation and start defining it, the second tab is always the one that is the active one when you jump into the dialog. Excuse me. And if you move to the right, you have the tooling tab. This is where you get to define your tooling. That's the 3rd tab. The 4th tab is where you set up feed rates. So these are your process parameters. The 5th tab is what's called the macro management tab. This is really what's used to control your engagements and your retract. So that's how the tool engages the material, retracts from material, and so on. Really important to prevent the tool from crashing into the part. And then if you double around and come back to the 1st tab, this is where you get to define your toolpath strategy. So for example, whether or not you are, as you can see here, working from the outward inwards helically, the spacing between toolpaths, how many paths you want depth-wise, as well as how many passes you want axially. So these are the 5 tabs, but you should always probably start with the geometry tab, which is the 2nd tab, to set up your geometry before you go to the others. So looking at this illustration here, there are a number of things that you can define. The first thing is to select the top plane, which for a facing operation, that's the top of the workpiece. So I'm going to go ahead and click on this plane, and then if I look at this part here, the top of the workpiece is going to be this surface here. So I'm just going to go ahead and click on this, and you can tell that it's been picked from the illustration because it turns green. So I've gone ahead and I've selected this top face, it's green. Now for me to select the actual surface of the part that I'm going to face down to, I have to pick this top face here. So in other words, this is where the material starts, which we've already picked. This is the depth to which you want to go. So I'm going to go ahead and click on this, and in this case I want to really pick this. I'm going to zoom in a bit. This face here, which is actually hidden behind the top of the stock. And one trick that you can use to help you pick things that are hidden, and you may have seen this already, is to hold on the alternate key, move the mouse over the surface or edge, if it's an edge. In this case it's a surface that you want to pick, as you can see here, and then I'm going to use my left mouse button and click. And what happens here is the CATIA drills down into the model, and it gives you a list of every single thing that is picked. You know, if you were to shoot a ray right into the screen, that ray hits geometry as it goes through the part. Everything that it hits is going to show up in this list, starting with what's closest to you or what you can see. So this is the top face that I can see. The next down is that face that I want to pick, and you can see it highlighted in orange in the spyglass window. So I'm going to click on that to select it, and you'll notice that everything shows up as green, which probably makes you happy. You think that everything is picked. However, it's a little bit deceiving in this case, because what happened here is CATIA picked the boundary of the face to be the boundary of this surface, because that's the surface I picked. So these green edges or faces here correspond to this outer boundary of the face that I picked. Now, is that correct for facing? No, because what we want to do is we want to make sure that the facing operation runs over the entire length of the part. We want to face down, but we want to remove material all the way over the top. So what I need to do is I need to, this is a case of CATIA maybe being too smart. What I want to do in this case is I want to remove these side faces. I want to turn it red again. So the way I would do that is I would move the mouse over it, right click, remove. So now I've removed the boundary of the facing operation. And where do I want the boundary to be? Well, I probably want it to be the faces that go around, wrap around the workpiece or the stock. So there are a couple of ways you can do it. One way is to pick the edges that make up the boundary. So to do that, you just have to click on the definition on the part of the illustration that is used to define the boundary. I'm going to click on it with the left mouse button. An edge selection window pops up here, but really and truly all you have to do is just go around and click on the edges that make up the boundary of what you want to face to. So be careful to pick the corner arcs. Make sure you get all of them, and then when you do, hit the OK button, and now we have everything green again. So we have the top of the material, we have what we want to face down to, and then we have the boundary or the extent of the facing operation. I'm going to show you another way to quickly pick the edges, because previously we just went around and selected everything, which can be kind of time consuming if you have a pretty large profile. It wasn't too bad in this case. We had 8 things to pick. So I'm going to go ahead and remove the selection again. I'm also going to go ahead and again left click on the face. I'm going to go ahead and click on this edge, and if you notice there's an arrow here which shows you the direction that you're moving around. If I go to the edge selection menu, you notice here if you move the mouse over, there are different options that help you to pick edges. One of these allows you to navigate on edges until another edge. So the idea being that because these edges are connected, CATIA can automatically navigate on them until it reaches an edge that you pick. So I'm going to go ahead and pick this option here, and then I'm going to select this edge, and notice what happened. It's kind of hard to see, but CATIA picked pretty much the remaining edges all the way around to that edge I picked. I still have one extra edge to do, which is this arc here, so I'm going to click on that to complete the selection. So these tools here, these edge selection tools, are actually a number of them that help you speed up edge selection. You can play around with these yourself and become familiar with them. So I'm going to hit OK, and now I'm back to my dialog box. Everything is green here except of course the fixture, and unless you have a fixture element, it's not absolutely necessary for you to define that. In this case here we don't have any fixturing to worry about. So I'm going to move over now to the third tab, which is the second one that you need to define, and this is our tooling, the cutting tool that we're going to use. If you go down to the resource tree, you'll see that CATIA added an end mill to the tree when you define the facing operation. Now obviously an end mill is probably not what you want to use to do facing, so we're going to have to change this. So let's look at the tool definition window. What you have here is again an illustration that shows you the parameters of the cutting tool, the various lengths. If you hold down the control button and click on your left mouse button, you notice that you can pan in and pan out. It's a little bit sticky on my computer today. but you have the ability to move around in this window here just like you do any other window. It's basically a window that's controlled by the mouse, just like the main graphics window. And if you want to reframe and get the image back, let's say you scroll it and it's too large, you can right click and you can reframe so it's back to the original size. Okay, what I'm going to do here is I'm going to switch to tool. If you notice up here there are 3 buttons. Right now it's set to end mill, and that's why we have an end mill showing up. I'm going to switch this over to face mill, and notice that the picture changes. It's a little bit larger. So I'm going to hold on the middle mouse button and the right mouse button and zoom in so I can see a little bit more what parameters are there. You probably want to change the name of the tool and make it more descriptive. So right now it's telling me tool 1, face mill, diameter 1.9. I'm going to actually create a 2-inch end mill, so I'm going to just put 2 inches in there to designate that it's a 2-inch end mill. Notice that the name of the tool down here changes to match. And now I'm going to start changing the geometry of the tool to make it a little bit more closer to what I would like to have. Before I do that though, notice that there's a more button here. If I click on this more button, it expands out and it shows pretty much the same parameters that are in the picture listed one under each other over here on the right. So I can change the geometry of the tool either by changing these parameters here or by changing them in the window. What I'm going to do here is start by changing my DA. Now this is the actual diameter, maybe the diameter of the body of the cutter. This should be larger than D. So let's go ahead and make this 3 inches to start off with. And I'm going to change the angle. I'm going to be using a 45-degree angled insert, just like the ones we use in our lab for our machining. I'm going to change this to 45 degrees. And then I'm going to change the D to 2 inches. So CATIA kind of plays around and sometimes changes these numbers to different values even though you've set them. And that has to be because of the way things change as it tries to solve the geometry. So I'm going to go ahead and maybe make this length here a little bit larger. I'm going to make this, instead of 0.5, let's increase it to 0.75. And as you can see now, it's starting to look a little bit more like a cutter. There we go. I'm going to also change the radius down here. This is the corner radius. There's a corner radius right on the tip of the insert. That's very large. I'm going to reduce this down to 20 thousandths, 0.02. So one can hardly see that radius. Now the other dimensions aren't too important. You can change those if you want to make the cutter look closer to the real thing. But those are the main ones for a facing cutter. This D here, which is your actual cutting diameter. DA is the body of the tool. It should be larger than D. This length here, LC, is the length of the insert. So you may also want to change this. This has to be larger than your depth of cut. So maybe you want to make this, let's say, 0.25. We're only going to be removing 100 thousandths, so this should be more than enough. And then of course your angle to make sure it matches up with the 45-degree insert angle that we have. So that's the geometry of your cutting tool. As you can see up here on the right, there are these tabs here too. So the geometry corresponds to what we see here. If we move over now to the next tab, which is technology, this is where we get to put in things like the number of flutes, the type of material that the tool is made out of, and so on. And it gets really involved here. There's a lot of information about geometry which you probably don't need to put in. So I'm going to go ahead here and just go ahead and maybe reduce this to 4 flutes to match up with the type of tool we have. Right hand tool, it's the type of tool that we use. We're going to use it both for roughing and finishing. Composition, it's an insert holder. And then the tool material, we're going to use coated carbide. And then, as I said, the rest of this information down here is really not that important. Again, it's more maybe for passing on information about the cutting tool for somebody who might be setting up a cutting tool for the project. So that's the second tab. The third tab is the Feeds and Speeds tab. So if you click on this, you'll see that there's a range of different parameters that you have to input. There are finishing parameters up on the top and roughing parameters down on the bottom. So I'm going to go ahead and work with the roughing first. You have here roughing cutting speed and roughing spindle speed. Now, it probably makes most sense to program with your spindle speed, because you'd have probably applied your speed and feed formula and come up with a spindle RPM already. So let's select this button here to indicate that we're going to define the speed. Now, if you think about this, this is a 2-inch cutter. It's made of carbide. If we apply the formula, 4 times surface feet per minute over diameter, for aluminum, we have 4 times 250 surface feet per minute. That's 1,000 divided by 2, which gives us 500 RPM. But then we double up again for carbide. So we'd expect our roughing speed to be 1,000 RPM, or 1,000 turns per minute. Notice that CATIA automatically calculates the surface feet per minute. So that formula that we just used, it pretty much inverts that and calculates the surface feet per minute. Now notice this, that it's not exactly 500, and the reason being that it uses the precise formula to do this. So now that I've got the cutting speed set, let's look at the feed rate. Now this is the roughing feed rate per tooth. So remember, we have four teeth in our cutter. So I'm going to set this to 0.005 inches per turn. And you notice now that the roughing feed rate becomes 20 thousandths inches per turn. That's because it's the feed rate per tooth times 4 teeth. That gives us 20,000 inches per turn. And then if we multiply that by the roughing spindle speed, that should give us 20 inches per minute, which is probably what we want to be feeding at for facing. So that would work there. So that's the roughing cutting speed, and then we have the option to come up here and also set it for finishing. So one could probably run it a little faster for finishing. That's assuming, of course, that you are going to be creating a finishing pass. So let's say we set this up at 1500 RPM, and then maybe we can slow it down a little bit, maybe for finishing. In terms of feed rate, let's feed it at, let's say, 2 inches per turn per tooth. So that will slow it down a little bit if you want a faster RPM, slower feed rate. Again, you don't have to do this. It may be just as fine to leave it at your roughing cutting speed and roughing feed rate. So that's how you set up the roughing, the speed and the feeds for your tool. Now I should tell you that in addition to feeds and speeds for the tool, you also have the option to set the feeds and speeds per operation. The reason being is that once you create the tool in the tree, you can use it for different operations. So what if you have an operation where you want to change the feed rate and speed? Are you totally stuck because it's already set for the tool? No. The reason being, or the way you would change it, is with this fourth tab over here. So this fourth tab, you'll notice here that the machining speed is grayed out. This value here is the value that's calculated from the tool, what you just defined. It's copied in here. Finishing feed rate is also copied in here. But you have the ability to override these if you want to by deselecting this checkbox up here. So now these fields become editable. So if you want to, as I said, if you reuse the tool in another operation, you may want to do this because those values that you set in the tool may not be the ones that you want to use. Now I'm going to just leave it checked off. Even if you don't change these, you do want to change your approach. Your approach is sort of like your plunge. So you probably want to be approaching at a controlled rate. I'm going to set this to be 8 inches per minute. And then your retract is the speed that you pull away from the part at. And again, unless there's some overhang, chances are you're not going to hit anything. You can bump this up. So I'm going to put this at 40 inches per minute. Okay, so that's the fourth tab. So again, make sure you set your approach, make sure you set your retract. We know that you don't do this when we see a feed rate of 0.04 in your G&M code that's generated. That probably means that you did not set your retract rate to a meaningful value. And what would happen then is you'd be moving the machine at a very slow rate, take forever to machine. So please set this as well as your approach. I'm going to skip the last tab for the moment. This is where we get into engage moves, approach moves, retract moves. It's important, but for now let's just skip this one and move to the first tab. And this is where we set up our toolpath strategy. So what I'm going to do is, first of all, I'm going to change my toolpath style. So right now you can see that the style is inward helical. The picture here helps you understand what's going on. So what's happening is the tool moves around the outside, moves into the next pass, and so on until it gets to the center. Probably for facing this part, I'd rather move the tool from one side to the other and zigzag back across. So what we're going to do is change this to back and forth, which you can see here. And in this case, the tool zigzags back and forth across the surface. Machining tolerance and fixture accuracy. Machining tolerance is really more important if you have toolpaths that are curved. You'll notice that these question marks here beside the various parameters, these can help you understand what the parameter is referring to. So if I click on this question mark, you'll see the picture up here where the machining accuracy refers to the deviation of the actual toolpath from the actual geometry of the part. And again, as I said, it's really more critical when the path that you're following is curved. So we don't really need to play around with these. They won't really come into effect for a facing operation. Let's move over to the radial tab, and this controls how far the tool steps over as you move from one pass to another. So we'd probably like to start the tool somewhere off the part and then step it over a certain amount. Remember, when you do step overs, to have some overlap between the tools, the passes. So let's look at the various modes for controlling our step over. There's tool diameter ratio, and again the question mark, if you click on this, it shows you what that means. So it gives you the ratio of overlap of the tool as it moves along successive passes. So in this case, you can see here it's set to 50%, which is kind of a lot. You could probably reduce that a bit. The other option is maximum distance, and this looks at the spacing between the tool paths. So instead of putting a percentage overlap, you have to put in a value in inches in this case. So of course, because our cutter is 2 inches in diameter, we do not want to be more than 2 inches between passes. Actually, you want to be less than 2 inches so that there's a bit of overlap, and that's what you type in here depending on what you decide. And then there's also step over ratio, which looks at the amount of space where the tool isn't overlapping. So it's kind of the opposite to the tool diameter ratio. I'm going to go ahead and look at the tool diameter ratio, and I'm going to maybe set my overlap to 10%. The other options that are available here are your end of path. So if you click on the question mark here, it shows you where the cutter will stop when it gets to the end of a path. It's a good idea to move the cutter off the part, particularly if you want to make sure that you don't leave cutter marks on the surface. Now if we look at this part, eventually, because of this step down here, we're going to remove a lot of material, so maybe we don't need to have the cutter, move off the edge of move off this edge, but probably on this side we would, because again this face is probably going to be remaining, definitely going to be remaining. So in this case, I'm going to go ahead and set this to out, so that you can see from the picture here that the cutter stops off the edge of the part. And then the overhang, this refers to, if you click on the question mark, how much overhang will the cutter have on the top and the bottom. I'm going to leave this at 50%. So 50% of the cutter will be off the part, assuming the toolpath runs on the top or the bottom. And then finally, there's this side approach clearance, and that gives you a little bit of an extra standoff from the cutter when it gets to the edge. And right now it's 0. Let's go ahead and put 100 thousandths in there, 0.1. So that's the radial control of the cutter. There's also an axial tab, and this controls the number of levels that one is going to cut. So in this case, we have a number of options here: maximum depth of cut, number of levels. I'm going to just leave the number of levels to 1. And notice that CATIA automatically calculates the level depth. The distance between the top of the part and the top of the workpiece in this example is 100 thousandths. So with 1 level, we're removing a maximum depth of cut of 0.1. If you had more material to remove, you might have 2, maybe 3 passes. If I type in 2 here, notice that it adjusts it to 50 thousandths per pass. So I'm gonna just leave it at 1. And then the last tab here is finishing. Do I want to have a finishing pass? Yes or no? Let's say we did want to finish. We could add a certain finishing allowance to leave, maybe 10 thousandths, 0.01. So CATIA will leave 10 thousandths for that last finishing pass. Okay, so we're almost ready to generate our toolpath. One thing to point out is we need to look and see which direction the toolpaths are being generated. If we need to change the direction, we can use this arrow here, pick on it, and select a different direction if we find that the toolpaths aren't going the way we want. But let's go ahead and generate the toolpaths first to see what we get. To generate our toolpaths, we use the toolpath replay button, which is on the bottom right hand corner of your dialog window. Let's go ahead and select this, and there you see the toolpaths generated. You notice that there are a number of different colors. There's yellow, there's red, blue, and if you go in close enough, you'll see that there is a cyan color and a green color. So it's kind of important to know what these colors mean. If you're not seeing colors, you may want to look at this simulation parameter window. There is a tool up here, the third one over. If you click on the little black triangle, this is your color mode. If for some reason your colors are all one color, green, it could be because your mode is set to a single color or same color. Make sure it's set to different colors so that you can see the different colors in your toolpath. Now, what do these colors mean? Well, the yellow color is an approach move. So this shows you the approach of the cutter. This long move here is probably an approach move from the tool change position. This yellow color here is your plunge move or your approach move, where the tool moves down towards to depth. And again, we didn't set our approaches and engages, so right now it may not be quite correct. Green is feed move, so this is when the cutter is down to depth and cutting material. The cyan color, this is your finishing pass, so CATIA distinguishes between roughing passes, which are green, and finishing passes, which are cyan in color. And then finally, the red move is a rapid move. There's actually one more move over here, which is a dark blue, and that blue refers to a retract. So that's a tool lifting up after it's finished, and then probably repositioning to the next pass. So we have our toolpaths. We can go ahead and replay this, so I'm going to go ahead and rewind to the start of the toolpath by clicking on the rewind button. and this may go very quickly, so I'm going to click forward, and we see the tool paths being regenerated. So as I said, you can see the tool paths being generated. It moves very quickly, in this case the cutter. It actually went through twice, once for the roughing operation and then one for the finishing operation. So that's a bit hard to see. One can, if you want to, again I'm going to rewind the tool to the start, you can change the replay mode. So if I click on the black arrow, instead of continuous replay of tool, this is the first tool here on your toolbar, you can go down and you can set it to point by point replay of tool path. So I'm going to click on this, and then by clicking on the forward replay button, you can see the tool execute one tool path at a time. Now this could be a lot of clicking if you have a fairly large part with a lot of tool paths in it, so it probably doesn't work very well for many cases. In this case it's not too bad. So as you saw there, the tool lifted up, rapid it over. Basically now it's finished the roughing pass, so that's taking off 90 thousandths material, and now it's dropping down to do the finishing pass, and that's the cyan color tool path, and that gets you down 100 thousandths to the final surface. And there's your last retract move in blue. So that's a way of looking at the tool paths one by one. I'm going to switch this back to continuous replay and rewind. The other thing you can do is you can simulate material removal, and that's what this button does here. This is very similar to Vericut. So I'm going to go ahead and click on this, and what you will see here is a model of the workpiece, and then if I hit forward, again it moves very quickly. You see the cutter running through and simulating the removal of the material. Let's do that one more time. So it gives you the ability, just like with Vericut, to see the actual removal and then eventually compare the machine part to the actual final design, the design that you want to have. Okay, so that's how you set up a facing operation, and how you display the tool paths, how you simulate material removal. Once you've done with this, just a couple of other things to point out. You have some indication of machining time here. I wouldn't rely too heavily on this at this point in time. There's certain things that have to be tweaked in order for this to be correct. But what you want to do is hit the OK button. This gets you back to your facing dialog window, and then don't forget to hit the OK button here. If by chance you hit the cancel button, all your work, everything that you just did, is gone. So be careful about this. When you want to leave operation dialog in order to do something, and if you want to save the work that you've done, always leave by hitting the OK button. I'm going to go to the tree now, and just to show you where that operation was created. If you remember, when we started this tutorial, you picked the facing operation and then you clicked on the manufacturing program. Well, now you can expand out the manufacturing program. What you see in there is a tool change. So the tool change is also added whenever you create an operation to represent the tool being brought onto the machine or loaded onto the machine. If I click on the plus button next to this, I finally get to my facing operation. And actually within the facing operation you can expand this and actually see the tool path, an element for tool paths in there too. If you want to edit the facing operation, this is a case of double clicking on the facing operation, and it gets you back to the dialog window. So that's your first machining operation, a facing operation. Of course your part has a lot more to do on it. There are a lot of things we haven't covered yet, including how to set approaches and retracts, but the process that we followed to create a facing operation is very similar to what you will use for other operations. The big differences, of course, are the geometry that you need to pick, which will change, the cutting tool will change too, and then the strategies. You get into more advanced strategies, particularly if you're dealing with end mills and pocketing and so on. But that's pretty much it for this tutorial. Hope it makes sense.